Yeah, I know what you're thinking when you're looking at this problem. You're like, cancel the 7s! Cancel the 7s! You remember all that fraction simplification and canceling we did? Why can we cancel? I want to focus on that so we can understand when we can cancel and when we can't. So let's take a good look at why we can cancel here. We'll start, of course, by flipping the denominator. 7 times 5 is the same thing as 5 times 7. And we do that because then I can break out the 7s into their own fraction. Just using fraction multiplication. All we're doing here is using the same old good math rules we already know. Now, of course, 7 over 7, 7 divided by 7, that's just 1. And we get 4/5 times 1. And of course, that's just 4/5. And this is why we can cancel out the 7s. Because I know I can rewrite this as 4/5 times 7 over 7. That is 4/5 times a fraction that equals 1. Multiplying by 1 doesn't change anything, so that just goes away. And that's why we can cancel the 7s. Let's make sure we have this down. Try another problem here. Now you look at this and you're thinking, hey, 14 and 21, we can cancel 7s again. And you see that 8 and 48, we can cancel 8s too. And we'll see why doing the same thing we did last time. We'll start off by just rewriting the order of the denominator, 48 times 21. And that allows us to break this into the product of two fractions that we know we can simplify. 8 over 48 times 14 over 21. We see 8 over 48, 8 is just 1 times 8. 48 is 6 times 8. We cancel out those 8s. We'll have a 1 in the numerator and a 6 in the denominator. 14 over 21, those are both multiples of 7. 2 times 7 over 3 times 7. Cancel those 7s, and we're left with 2 in the numerator, 3 in the denominator. Okay, so now we've got in the numerator, we just got 1 times 2. And on the bottom, we've got 6 times 3. And you're saying, hey, we can cancel out the 2's. Got a 2 up here, cancel out a 2 out of the 6. And we know why we can do that. We can rewrite this as 1 times 2 over 3 times 6. So we can break that up into 1/3 times 2/6. We know we can simplify that. 2/6 is the same thing as 1/3. So that's 1/3 times 1/3. That equals 1/9. Now, of course, I don't write out all these gory steps when I'm doing fraction simplification. Once I really understand why I can cancel, I do all my canceling right up here. Now, I'm a trained professional, so you got to do some practice before you do this at home. But once you understand that you can cancel, here's how you might do it. You'll look at this and you'll see 14 and the 21. If you're a football fan, you'll think 2 touchdowns, 3 touchdowns. 2 times 7, 3 times 7, cancel out the 7s. You'll cancel out the 7s, you'll leave a 2 in the numerator and a 3 in the denominator. You'll see the 8, you'll see the 48. You'll say, hey, those are both multiples of 8. That's 1 times 8. That's 6 times 8. I'm going to cancel out those 8s. I'm going to leave a 1 in the numerator and a 6 in the denominator. Now notice this is just the same thing as what we're doing down here. 1 times 2, 3 times 6. 1 times 2, 3 times 6. It's the same thing. Down here we went through the gory steps to see why it works. Now here's how we do it in practice. We'll take the 2 and the 6. We'll see that, well, we got another 2 we can cancel. Take a 2 out of the top, leaves a 1. Take a 2 out of the 6 down here, that leaves a 3. Our numerator is left with 1 times 1, which of course is 1. Denominator is 3 times 3, and that's left with 9. Now the reason we really want to understand canceling is so that we can understand when we can't cancel. Now check this out. Now I know some of you at home are thinking, cancel the 3's, 1/5, cancel the 3's. Notice I didn't write that down. That's because it's wrong. Right, let's go ahead and compute. 1 plus 3, that's 4. 5 plus 3, that's 8. 4 over 8, you recognize that number, right? That's 1/2, not 1/5. You can't just erase those 3's and forget about them like we were doing with multiplication. These are sums in the numerator and the denominator. Now maybe you're thinking, hey, cancel the 3's and leave ones there. So it'll be 1 plus 1 on top and 5 plus 1 on the bottom. Notice I'm not writing that down either, because that's also wrong. 1 plus 1 is 2. 5 plus 1 is 6. 2 over 6 is 1/3, not 1/2. We can't multiply, we can't cancel the 3's. We can't cancel the 3's because we can't rewrite this fraction as something times 3 over 3. We can't just move the 3's out like we moved the 7's out here. Here, we were able to rewrite this as 4/5 times 7 over 7 using perfectly good math rules, and that's why we could cancel here. We can't break the 3's out here. We can't do that. We don't have any math rules that allow us to do that, and we can only do what the math rules let us do. We can't cancel. Two products, cancel. Two sums, no canceling. What about a product and a sum? Can we cancel the 5s? Can we cancel the 4s? Can we do anything here to simplify this fraction? Well, we can't use the same sort of rules we did with multiplication to break out the 5s. We can break out 1 5, we can't break out the 1 on the bottom. So, can we simplify anything at all? Let's go ahead and compute and see if it's at all possible to simplify this fraction. The numerator comes out to 20, and 4 plus 5 in the denominator is 9. There are no common factors besides 1 here. We can't simplify this fraction, so we can't cancel anything out of this fraction. There's no canceling to be done here. So, 2 multiplications, we can rewrite it as something times 1. We can cancel. 2 sums, no canceling. A product and a sum, still no canceling. I can't rewrite this as something times 5 over 5 or something times 4 over 4. Pull those out. I can't. All I can do is write 20 over 9, and we have to stop here because we're done.